Okay, looking at equations and units practice number 3. Right, same format as always, extract your data, look at what you're using. Choose your formula, check your units. Substitute in, solve it, round, significant figures, add the correct unit at the end. Follow that pattern and you're going to do well. Okay. A diamond ring has a mass of 0.5, so we've got mass 0.5 kilograms. A volume of 0.025 centimetre cubed. Calculate the density. Right, so from memory or from your equation sheet, we've got density equals mass divided by volume. And mass is in kilograms. Volume, not kilograms, is it? It's grams. God, imagine that. Half a kilogram of diamond. That'd be just fantastic. Volume is centimetre cubed. So from density, we can now work out the units. It is grams per centimetre cubed, because we've got grams at the top and we've got centimetres. Substitute in. Mass is 0.5 grams. Density is volume is 0.025. Density is 20 grams per centimetre cubed. Next question. So what we've now got is a 2.5 kilogram bucket of water. So we've got mass and it's 2.5 kilograms kg. Has evaporated. The specific latent heat, so specific latent heat of vaporization is 2260 kJ per kilogram. Calculate how much thermal energy, okay, is needed to change it from a liquid to a gas, okay, because that's the latent heat of vaporization, is liquid to a gas. Right, so thermal energy, I'm just going to put thermal energy equals mass times specific latent heat. Okay, problem here is I know that it is joules per kilogram is my specific latent heat. Right, so I might have a bit of a problem. Okay, so I've got my formula. Now I need to check my units, and because that is kilojoules per kilogram, I now know it's going to be 2260, and I'm going to add on 3 noughts because I've got to convert it into joules. So thermal energy, mass is 2.5 kilograms, multiplied by 2260, make sure you use your calculator, 000, equals 5650,000 joules. Now let's say they did want to put it into kilojoules. Then what you do is divide by 1,000, so it'd be 5650 kilojoules. An astronaut has landed on Mars. The astronaut has a mass of 70 kg. The gravitational field strength is 4 newtons per kilogram. What is his weight? Okay, so we need to either remember or we need to look up our formula, and it is weight equals mass times gravitational field strength. So weight is what we're working out. Units seem good. 70 because we have mass in kilograms. Gravitational field strength is 4. 70 times 4 is 280 newtons, because that's then the units of weight. A husky pulls a sled 500 meters, so distance 5,000 meters rather, with a force of 25 newtons. Calculate the work done. Work done is measured in joules. It's the amount of work that is then done by that lovely fluffy husky. Okay, so from memory, formula, it's better if you can do it from memory. If not, look it up on the equation sheet. Work done in joules equals force in newtons times distance in meters. Meters is right, newtons is right, we're working out in joules. So the force is 25 multiplied by 5,000 equals 125,000 newtons. Joule, what am I doing? Newtons. Right, my answer's work done. Joules. Lost the mark then. A piece of bubble gum with a spring constant, so spring constant is 1.2 newtons per meter, is stretched 0.7, so extension is 0.75 meters. What is the force? Okay, so force equals spring constant. So force is in newtons, spring constant is newtons per meter, multiplied by extension. Okay, and luckily extensions in meters, or else I'll have to convert. Spring constant is 1.2 multiplied by extension 0.75. 1.2 times 0.75 is 0.9 newtons. Right, again, that's practice. You just got to keep practicing and practicing and practice, because the more you practice, the more familiar you're going to be with the units, the more familiar you're going to be with the equations.